Today we have to discuss about the topic speed control of three-phase induction motor. In our daily life, we have to control speed in many other applications such as car, bike, fans. In fan we have to regulate speed. In car we have to regulate speed. In mixer grinder we have to regulate speed. Let us discuss about this speed control. And its introduction. A three-phase induction motor is basically a constant speed motor. Speed of a DC motor can be varied very easily, but in an induction motor, speed reduction is accompanied by a corresponding loss of efficiency and power factor. As induction motors are widely used, their speed control may be required in many applications. Yes, thus applications such as car, bike, etc. Now, there are two major methods of induction motor in speed control. First method, speed control with respect to stator side of the induction motor. Second method, speed control with respect to rotor side of the induction motor. First method, speed control of induction motor on stator side. In this stator side speed control, there are three different methods. First method, by changing the supply voltage of the motor, by changing the stator pole number of the motor, by changing the frequency of the supply side of the motor. Let us discuss about these topics. First method, by changing the stator pole number of the motor. The primary factor in determining the speed of an induction motor is the number of poles. In this photo, we have to see the formula. Ns is equal to 120 F by P. P is number of poles, F is line voltage frequency in Hertz, and Ns synchronous speed in RPM. This formula is used to find synchronous speed in RPM. But in changing the stator pole number of the motor, the poles plays a major role. If we add poles, if we remove poles, that is the main reason we have to change the stator pole number of the motor. In this, the poles will play the major role, as I said earlier. If you have poles, if we add poles, it shows a different output. If you remove poles, it shows various output. Such that we have to change the stator pole number of the motor. Next method, changing the frequency of the supply side of the motor. In this, frequency can be changed. By changing the supply frequency, the motor synchronous speed can be altered, and thus the torque speed of the three-phase induction motor can be controlled. The synchronous speed of the motor at rated condition is known as the base speed. The base speed is defined as the synchronous speed of the motor at rated condition. By using variable frequency control, it is possible to adjust the speed of the motor either above or below the base speed. Yes. And also frequency is directly proportional to the torque speed. Now, in that, if we increase in frequency, the torque is also increased. And also, if we decrease the frequency, it decreases the torque speed. This is the relation. Frequency is directly proportional to the torque speed. Then, speed control of induction motor on rotor side circuit. In this rotor side circuit, there are three methods. First method, adding an external resistance into rotor side circuit. Second method, applying cascade connection. And third method, injecting EMF into rotor side circuit of the motor. First method, adding an external resistance into the rotor side circuit. In this method, we have to add the rotor in the external resistance. the external resistance is placed in the rotor side circuit, so that we have to change the rotor speed. By changing the rotor speed, the machine speed can be controlled. Let us discuss about this method. This method is applicable only when the wound rotor induction motor speed variation can be obtained by inserting external resistance in the rotor circuit. External resistance are placed in series. That external resistance are placed in series with the rotor winding during starting, so that we have to limit the starting current. Without the external resistance, the starting current are many times the rated current. If we can't add resistance, the starting current are many times the rated current. The starting current are even very high as the rated current. Depending on the size of the machine, it can draw 300% to or 900% of the full load current. Once the motor is started, the external resistance can be cut out to obtain high torque throughout the accelerating range, so that the motor can be applicable to start. Once the motor is started, the external resistance can be cut out to obtain high torque throughout the accelerating range. In this method, the resistance plays a major role, and resistance is used to control the speed of the motor. Next method, cascade connection method. In this cascade connection, the diagram are shown in figure. First, there are three-phase supply, then motor A, motor B, slip rings, the connection between slip rings and the motor B, and then finally frequency EMF. Now, let us discuss briefly. In this method, you have to control two motors. There are two motors are mounted on the same shaft. We have to see this diagram. Motor A, motor B. There are two motors are mounted on the same shaft of the motor. Are mounted on the same shaft. Okay. And run at same speed. One motor is connected to three-phase supply. This motor is connected to three-phase supply, and the other is work from the feed induced EMF, and the other motor is work from the feed induced EMF. The slip ring is performed in between the motor A and motor B. By using this method, different speed can apply for induction motor and speed can control very easily. In cascade connection, we have very few times to control speed. This is a very easy method to control the speed. And then injecting EMF into rotor side circuit of the motor. In this induction motor speed control method, external voltage add into the rotor circuit. Before we have to add the resistance in the rotor side, but now we have to inject EMF on the rotor side, EMF and frequency, EMF side frequency of the motor. In this induction motor speed control method, external voltage add into the rotor circuit of the motor and the frequency must be same as slip rings. So injecting EMF in opposite phase of the rotor increases the rotor resistance. By that, this method can used to speed controlling of the induction motor. In this method, external voltages can be added into the rotor circuit of the motor and the frequency is set to slip rings frequency. So injecting EMF in opposite phase of the rotor increases the rotor resistance. By this method, the speed can be controlled by this method. Thank you.